Welcome everyone in the lecture number 8 of the route choice or the network selection. In that specific lecture, we will mainly talk about the route or the path which we use usually to complete our journey. The route assignment or route choice or the traffic assignment or the network selection is actually the activity that about the traveler in order to predict that which specific route he or she will use to complete his journey from origin I to destination J. This is the last step of the conventional model. As you can see here in the second slide, we would like to understand that what are the factors which affect on our route choice. For example, the traveler would like to go from origin 2 to destination 0 or from 1 to 2. Okay, so he can go through two options, either route 1 or through route 2. But before to select those route, we usually try to understand the different characteristic of route 1 and route 2. As it's mentioned in that graph, that what are the facility type available among route 1 and route 2, as it give the kind of all the options which is physically separated from other modes. Is it have a dedicated route, or it have a autobahn or something which have no speed limit? Is it have contain the more congested route 1 or 2? And the second part is about the surface quality. Surface quality is very much important in order uh, to select your route 1, 2, or among route N, because if it's smooth surface, so we have a good asphalt with very less cracks, and the speed is according to our desire. But if it's moderate, so it means that the same option or the surface also kind of have little bit bumps, and which could reduce or uh, kind of travel speed as well. The third part is roughness. If the roughness is at a very high level, so we will never select that route as well. If it's too much shortest as well. Okay. The second part is about the level of the traffic. If the traffic is light, moderate, or heavy, so if it's light, we usually select that part. If it's moderate, we can also again select it. But if we have the gridlock situation always, then we usually avoid that part as well. So again, travel time. So in like how much time we can get there. For example, if it's a short travel time, medium travel time, and long travel time. So those are the factors which usually affect on our route choice to go from any origin. So how we can determine the route choices? We usually use different kind of algorithm in order to determine the route choice, such as minimum path algorithm, minimum time path, and the Dijkstra method. Okay, so the shortest path algorithm, which usually calculate the short path from start node to each node, so that to connect the graph. Okay, so what is the purpose? Basically, the purpose of using all those algorithm method is to find a path between any two vertices. Okay, origin I and J, so those we call nodes or vertices, and the route which we actually use it is called edge. Okay, so always we have one the source vertices, and the another one is path algorithm. As you can see here, we have 5 different modes: 1, 2, 3, 4, and 5. In that slide, is you can see here, we have different routes and travel time is possible. So for example, if you would like to go from 1 to 2, from one way it's cost or travel time is 3 minutes, but from the 2 to 1 is 4. Okay, so we just so this is the trips which actually generate between 1 to 2 number of the trips. Okay. As you can see here, while using the to determine the best route from 1 to 5, so we have different options. For example, what you will do, So always we will take one reference point and another one will be your destination, and we will try to determine the number of choices and the travel time from I to J, from your reference point to your destination point. And then in the last part, we will come up with the selected route as well. And we will also find out the redundant route which have the high impedance value or the resistance factor. So for example, if we consider point one, reference point one, and we would like to go to two, so we have only one option. We can only go from one to two. Okay, route choice two, and the travel time from one to two is 3. Okay, so we selected the route 2. And in the next part, while going from 1 to 3, so which is adjacent to 1, so we select the same route. So we have the reference point 1 while the destination 1 is 3. So we can only go through a single route. OK, so through route 3. So its travel time is 5. Similarly, if we select 2 or 3, so for example, if we select 2, so we would like to go to 4. OK, while going to 4, so the distance from 1 to 2 was 3. So 3 plus 2, which is equal to 5. OK, and similarly, now we will select another route, for example, from 2 to 1 to 2 is done and 2 to 4 is done. Now we will select from 3 to 4. So now we will go from 3 to 4. So the distance from 1 to 3 is from 1 to 3 is 5. OK, and from 3 to 4 we have the distance of 6. So 5 plus 6, which is equal to 11. OK, sorry, I just put there 10. So which is equal to 11. OK, so while the distance from 4 to 5, while using that route 1, 3, 4, 5, so we have the distance of 5 plus 6 and plus 7. 5 plus 6 plus 7 is equal to 18. OK, and then the another route to reach from 1 to 5, we have 3 plus 2 plus 7. 3 plus 2 plus 7 is equal to 12. So the selected route is to come to reach from 1 to 5 is to go from 1 to 2, 2 to 4, and 4 to 5. So we have selected this. The last model, we have the Dijkstra method. In that method, we would like to see that how we can reach from any one mode to the other mode. For example, the nodal point that we will call node or vertices, and the one which is from where we would like to go. So the route or the link which we will use, we will call that edge. OK, the one from where we would like to go, for example, is you can see here in that specific table, while going from 1 to 1. So we will always start with, we will assign the value 0 to that, and to the other node, we will assign the infinity. OK, so while going from 1 to 2, we will use the edge 1, which distance is 1. So our source vertices is 1 while destination vertices is 2. OK, while going from there, so 1 is directly connected with 2. So we have the value of 1. And then 1 is directly connected with 5. So we have a value of 10. And 1 is directly connected with 4. So we have the value of 3. Now what we will do, we will always select the minimum value. So in the second stage, we have the minimum value is 1. So we select 1, so which is node 2. So the minimum node or vertices is selected is node 2. So now we will proceed that method from node 2. So now our next reference point is 2. So while going from 2 to 0, so the same value will be repeated till the last. So we have uh, the distance from 1 to 2, which was before is 1, while from 2 to 3, we have the previous value was 1 plus 5. So we have the new value of 6. OK, the previous value of the 4, because 2 is not directly adjacent vertices are directly connected with node number 4. So we will use the same value again. OK. Similarly for the node 5 as well, which is 10. So among those, so now we already select node 1. We already selected or visited node 2, and we are so now we will select value among 6, 3, and 10. So among those, we have the minimum value of 3, which is node 4. So now we selected node 4. So now going from node 4, the previous value was 0 and the previous value was 1. So we directly repeat that part. Now, while going from 4 to 3, OK, 4 to 3. So from if you can see here from node 1, we had the previous value of 3. OK, so now we will repeat that part from the previous value was 6. So now we will again re-measure it. If the new value is less, then we will select that root. So now we select 3 plus 2, which is equal to 5. So now we will select that part. The previous value is 3, which is again selected. While going from 4 to 5, now we have the new value. The before value was 10. So now we are going to recalculate it. If the new value is less than 10, then we will select that one. So for example, 3 plus 6, which is 9. So now we select root number 9. As you can see here, we have visited to node 1, node 2, node 4, node 3. Now we have our last node, which is node 5. OK, so now we are standing at node 3. So the previous value will be repeated. So now we would only like to see that going from 4 to 5, from 3 to 5, like that. For example, before value we had here 4 to 3 to 5. So 1 plus 5 plus 1. So the new value is 6. OK, 5, 1 plus 5, and then plus 1, which is equal to so it will be 7. OK, so the 5 plus 1 is equal to 6. So the node number 5 is selected. So this is the the uh, uh, the method through which we determine from zone 1 to zone 5